Math 100 Lesson 6.6 is solving quadratic equations by factoring. And so all in Chapter 6 we have done all this factoring business. And so now we're going to learn why exactly are we factoring. We are factoring because that's what we use to solve quadratic equations. And so the first thing we need to know is what exactly is a quadratic equation. Well, its standard form looks like this: ax squared plus bx plus c equals 0. So the first part, the ax squared plus bx plus c, should look very familiar to you. That was what our trinomials looked like. The only thing new is this little equals 0. So anytime we are asked to solve a quadratic equation, the first thing we want to make sure is that it is equal to 0. All right, that's going to be our first order of business, is make sure it equals 0. All right, and so let me show you how we're going to use our factoring to help us solve. All right, so our directions are just solve. And when you see the word solve, that means you're trying to find a value that works when you plug it in for the x value. So what we're doing is we're trying to find x. That's what solve means. Find the value of x. All right, so what we are going to do, we first make sure that it's equal to 0, and in this case it is. Okay, and so that's our first thing, is does it equal 0? Yes, check, it does. The next thing we're going to do is, let's factor. Okay, and so when we factor, we go through all the steps that we did on lesson 6.5, where I gave you that general strategy where first you look for the greatest common factor, then you look for special forms, and then you make sure that all your factors are completely factored, that they're done. All right, so here there is no greatest common factor, but we do have a trinomial. Okay, so I'm looking for two things that multiply to be AC and two things that add to be B. So in this case, that would be 10 and negative 7. So my two values are negative 5 and negative 2. Now I prefer faux fractions, but you still can group here. Okay, I will do this one grouping. Just FYI, I'm going to quickly turn into faux fractions and won't be doing much more grouping. But you are welcome to continue to do that, and if you have any questions, please let me know. All right, so if I do my grouping here, bring my first term down, minus 5x, minus 2x, and bring my last term down. And now that we have this equal 0, we have to also bring it down. All right, so now we will group. These have an x in common, so factor out that x, factor out this negative 2, and don't forget to bring down that equals 0. It is important. All right, and so now we factor out the x minus 5. We multiply it by the x minus 2. Bring down this little equals 0. All right, when we get right here, now we are going to apply the zero product principle. That's what this next step is called. The zero product principle. And essentially all it's saying is if I'm multiplying two things together, because this says x minus 5 times x minus 2. If I'm multiplying two things together, one of them has to equal 0. Okay, that's really all the zero product principle means. So what we do is we go, you know what, we're going to set both of them equal to 0. So once you get it factored, you set each factor equal to 0 and solve. So now we would add this 5 and we get x is 5. When we solve this one, we get x is 2. So in my math lab, they're going to want you to write your answers sometimes as a solution set. Okay, if they want it as a solution set, I just take my two numbers and I put them in these little braces that they will provide for me. They may have x equals, and then they may tell you to fill in the box and separate your answers with a comma if there's more than one. So make sure you read the directions in my math lab for how it wants you to put in your answer. All right, let's try again. Okay, our directions are still solve. All right, so this problem really is easier than the last problem because it is already factored. We don't have to do the factoring. It has already been factored. Yay, that makes us happy. It's already been factored. So once I get here, now I just set each factor equal to 0, that little 0 product property, and solve for x. Divide by 2 on both sides, and so x is 1/2. Add 4, and so x is 4. Again, pay attention to how my math lab wants your answers. The solution set would look like this. If they want you to type in your answer in a box and separate it by commas, just make sure you pay attention to what the directions tell you. All right, let's keep going. We are still solving our equations. All right, so when I look at this problem, all right, big issue here is it's not equal to 0. All right, so it must equal 0. All right, we have to do that first. And the only way I can get it to equal 0 is if I subtract from one side to the other. Dividing is not going to give me 0, that will give me 1. So I am going to subtract 2x from both sides. Now, when I do that, it is not like terms with that 4x squared. So it just has to sit beside it. So I have 4x squared minus 2x. Now it is equal to 0. So now I factor. So I go through my little process. Is there a greatest common factor? Yes, there is. It is 2x. When I divide it out, I'm left with 2x minus 1. Once you have your factors completely factored, now you set each factor equal to 0. That's that 0 product property. The directions will use that phrase, so I want you to know what it's talking about. The 0 product, I think they say principle, not property. Okay, so one of my factors is 2x. I set it equal to 0. My other factor is 2x minus 1. I set it equal to 0. Now I solve both of these. 0 divided by 2 is 0. Okay, divide by 2, and I get x is 1/2. So here's what I see happen. People get an answer like x equals 0, and for some reason in our minds, we're like, oh, 0 is not really an answer. Guys, 0 is a number just like 5 is a number. Okay, so 0 is an answer here. So my solution set, my two answers are 0 and 1/2. Again, pay attention to how my math lab wants your answers. And there we go. Let's try some more. So in this particular problem, again, it is not equal to 0, and it must be equal to 0. Now, one other thing I want to tell you here, when you set it equal to 0, kind of a little tip for you is I never want my ax squared term to be negative. If I have a choice, I do not want that thing to be negative. Okay, I don't want that ax squared to be negative. And in this case, that would be just the x squared. My a is 1. Okay, so I don't want to move that because it would make it negative if I move it. So I'm going to subtract 10x from both sides Now I'm going to do one step at a time just so that everyone can see exactly what I'm doing. These are not like terms, so I just have to put the 10x beside the x squared, and I'm left with negative 25. And then I would add 25 to both sides. So I have x squared minus 10x plus 25, because it's not like terms with the other two, is equal to 0. All right, so I now have it equal to 0. Now I factor. Look for a greatest common factor. There's not one. It is a trinomial. So I'm looking for two things that multiply to be a times c. Those same two things add to be b. So I'll just write them all down again. Last time I did not. All right, a times c is 25. My b value is negative 10. So my two numbers are going to be negative 5 and negative 5. That way when I add them, I do get negative 10. When I multiply them, I get positive 25. As promised, I'm going to do faux fractions. Take my a value with x, put it over one term. My a value with x, put it over the other one I found. All right, can't be simplified. So my factors are x minus 5 times x minus 5. All right, make sure you bring down that equal 0. It does matter. This is an equation. Once we get here, we set each factor equal to 0. Now I know these factors are the same, but I'm just going to go through the steps. So I get x is 5. Now, we're going to get 5 both times. We get x is 5. My solution set, guys, don't put 5 twice. Okay, it's just 5. Like, what answer goes in place of x? 5. Don't say it twice. My math lab will count that wrong. All right, moving along. All right, let's try this one. Now, there is more than one correct way to work this particular problem. All right, there is more than one correct way to start this particular problem. Now, I'm going to start with what we've been doing this whole time, and I'm going to do, it has to be equal to 0. Okay, so I'm going to subtract 25 from both sides so that it's equal to 0. All right, done. Now I'm going to factor. Well, there is no greatest common factor, but this is difference of squares. Having to recognize that. So the square root of 16x squared is 4x. So it goes in both parentheses. The square root of 25 is 5. One gets a plus, one gets a minus. So I have factored. Now I set each factor equal to 0. That is called the zero product principle. And solve for x. Now, when I get this answer, I end up with a fraction, which is perfectly fine. Just leave it a fraction, negative 5/4. Don't try to turn that into a decimal. And we get positive 5/4. So my solution set would be negative 5/4 and positive 5/4. There we go. All right. Hopefully this is making a little more sense to you about why did we even factor in the first place. But so we could solve these cool little problems. Okay. So we are asked to solve. Well, it looks like this one is already factored. I believe the second one I did today as an example was already factored. The problem is it must equal 0. And this one does not equal 0. Ooh. So I can't just subtract 28 because that stuff over there on the left is in parentheses. So the first thing I'm going to do is I am going to multiply that left side. I'm going to multiply that left side out. I'm going to start there. So distribute, distribute. Okay, so I get x squared minus 2x minus 5x plus 10. Still have this 28, haven't done anything with that. Now combine these two like terms in the middle. So x squared minus 7x plus 10 equals 28. Now I'm going to revisit this idea of, okay, it must equal 0. Because now I can subtract 28. Okay, I can subtract 28 now. And I get x squared minus 7x minus 18 is 0. All right, so yay, I got it to equal 0. Now I factor. There is no greatest common factor. It is a trinomial. So we're multiplying two things to give me a times c. And those two things have to add up to be b. My a value is 1. My b is negative 7. And my c is negative 18. So two numbers that multiply to be a times c be negative 18. My b value is negative 7. So my two numbers are going to have to be negative 9 and positive 2. I like faux fractions, so take my a value with x over one of the numbers I found, my a value with x over the other number I found. These cannot be simplified, so I read them. So my factors are x minus 9 times x plus 2. Now we do the zero product principle and we set each factor equal to 0 and solve. So I get x is 9 and I get x is negative 2. So my solution set is negative 2 and 9. All right, we are almost done. We've got one more example here, and it is probably going to be your favorite, a word problem. Okay, but it's a word problem that really kind of makes sense. I'm the teacher, so I guess it would make sense to me. Okay, so we've got the length of a rectangle. We all know what a rectangle looks like, so let's imagine a rectangle. The length of a rectangle is 3 feet longer than the width. Okay. The area of our rectangle is 54 square feet. And the question here is find the length and the width. Now I know that some of you could probably figure this answer out with just kind of trying numbers to see if they work. That's not what I'm looking for here. All right? When we have a word problem, I'm looking for a few things. The first thing I'm looking for is we need to define our variable. If you're going to use the letter X, then tell me what it represents. Okay? So I'm going to just draw my rectangle here so we can see what we're talking about. Now, I use the two words length and width in my problem, so I just want to make sure I know where that is on my diagram. This is my length, this is my width. All right. So let's say, I wrote wide, width. Let's say I am going to call W the width. All right, I'm going to let W equal the width. And I know that some of you immediately went in your mind to, okay, well then L is the length. No, we don't want two letters. Okay. If W is the length, now let's go back up to this first sentence where it says the length is 3 feet longer than the width. The length is 3 feet longer than the width. All right, so my length is whatever that width was, but it's 3 feet longer. So W plus 3. So I've got W plus 3 right here, and I've got W right there. All right. Now, the next thing that I need to look at in my particular problem here is this word area. Do we know how to find the area of a rectangle? Okay, the area of a rectangle is found by multiplying the length times the width. All right, that's how we find the area. All right, so they told us in this problem that our area is 54 square feet. So where I see this letter A, I'm going to put 54. We decided that our length was W plus 3. So I'm going to put W plus 3 where the word length is. And then we decided that our width was W. So I'm going to put my W right there. So now what we're going to do is solve this equation for the width. Awesome. Okay, the first thing I need to do is distribute that W through my parentheses. So W squared plus 3W. Remember, this thing must equal 0 if we're going to solve it. So I'm going to subtract 54. Now for some of you that just really bothers you that equals 0 is on the left instead of on the right, like all the other problems we just did. It doesn't matter if the equal 0 is on the left or the right. All right, and so now we factor. I'm looking for two things that multiply to be A times C. Those same two things add to be B. A times C is negative 54, and my B value is 3. Okay, so 9 minus 6. Okay, I like faux fractions. So I take my A value with the variable, in this case it is W, over 9. My A value with the variable over the negative 6. Neither one can simplify. So my factors are W plus 9 and W minus 6. Now we set each factor equal to 0 and solve. Okay, so we got two answers for the width. Now the problem, the question above says, find the length and the width. Well, we just found the width, and we found two answers. So let's think ourselves through this for a minute. My width is 6, and my width is negative 9. If we're talking about how long something is on a rectangle, that's what we're looking for. How long is it? What is the length? How long is the width? Well, it can't be a negative number. So we didn't do anything wrong, but this is definitely not our width. So when I list my width over here, my width is 6 feet. Our problem was in feet, so we're going to keep that in feet. Now our length, to find our length, remember, we said this. Our length is whatever our width was plus 3. So 6 plus 3 is 9 feet. So my width is 6 feet and my length is 9 feet. And that would be my answer there. So when you're asked to do these word problems, even if you're like, well, I found that out before we did all that crazy stuff. Well, that crazy stuff, the factoring, is kind of the whole point of the chapter. So making sure that you can write an equation and then solve that equation using the factoring that we've done in chapter 6. That's kind of the whole point here, is that we can factor. So section 6, this is it. This is the entire chapter 6. You have completely finished factoring. Now, I told you that factoring was super important. We will use it from here on out in Math 100. So please make sure if you have any questions that you let me know. This is not one of those things that you can afford to say, oh, I don't really get it, I'll just do better on the next chapter. Because factoring is going to be in the next chapter, and the next one, and the next one. So let's make sure if you've got questions, we get that taken care of. So I hope to see you in a Teams meeting.